Welcome to this tutorial on AcidBase Extraction.
An extraction technique can be used to separate a mixture if one or more of the components have acidic or basic functional groups. Let's look at a mixture containing an unreactive alcohol and a basic amine dissolved in an organic solvent. If this organic layer was treated with an acidic aqueous layer, such as an aqueous hydrochloric acid solution, we expect a proton transfer reaction to take place. The basic amine would be protonated by the acid to give an ammonium salt. The alcohol, on the other hand, has no significant reaction with the acid, so it remains neutral and therefore remains in the organic layer. Remember, like dissolves like. The ionic ammonium salt will be drawn into the aqueous layer because it is now charged. Typically, the organic layer would be treated with 2 to 3 fresh portions of aqueous HCl to complete the extraction of the amine. At this point, you can see we've effectively separated the two components of the mixture. But now, how do we get the amine out of the aqueous solution? To recover the amine, the acidic aqueous layers are combined and neutralized with base to regenerate the neutral amine. The aqueous layer is then returned to the separatory funnel and mixed with 2 to 3 portions of an organic solvent. The neutral amine no longer has an affinity for water, so it is extracted from the aqueous layer back into an organic layer, called a back extraction. Overall, this acid-base extraction process effectively separates the two components of the original mixture, giving each of them dissolved in an organic solvent that can be easily removed. Now, we've just illustrated how a basic component can be selectively removed from an organic solution by treatment with aqueous acid. And using a similar strategy, an acidic component can be selectively removed by treatment with a base. Even complex mixtures of neutral, acidic, and basic components can be separated using such techniques. So let's take a look at how that might be accomplished. When planning an acid-base extraction, we need to consider the various types of solutes that might be present in the organic layer. Neutral solutes are those that are neither acidic nor basic. This includes a wide variety of functional groups, including alkanes, alkenes, alcohols, ketones, alkyl halides, esters, and ethers, for example. Basic components are those that can accept a proton, such as amines, and acidic compounds are species that can donate a proton. In other words, they can be deprotonated. Acidic components can be described as either weakly acidic, such as phenols, with pKa's of approximately 10, or acidic, such as carboxylic acids, with much lower pKa's around 5. Now let's take a look at the types of aqueous solutions that are available for extraction. One option is to wash the organic layer with neutral water. Now, keeping in mind that like dissolves like, we wouldn't expect any typical neutral organic compound to have significant solubility in water, so we would expect all the compounds listed to largely stay dissolved in the organic layer. Other solutions that can be used for an extraction include aqueous acid, such as 10% HCl, strongly basic water, such as 10% NaOH, and mildly basic water, such as saturated sodium bicarbonate solution. Now let's look at each type of compound and decide how they would interact with the various aqueous layers. The unreactive organic solutes are neither acidic nor basic. They have no reaction with any of the aqueous solutions shown, so we expect these solutes to remain mostly in the organic layer. Since amines are basic, they do not react with other bases. Treatment with acid, however, causes the amine to be protonated, and because the resulting ammonium salt is ionic, it will migrate from the organic layer to the aqueous layer. A weakly acidic phenol does not react with an acid or with a weak base, such as bicarbonate. However, if a strong base is used, then the phenol becomes deprotonated. The resulting phenoxide ion is water-soluble and would be extracted into the aqueous layer. Lastly, carboxylic acids do not react with the acidic 10% HCl solution, but are readily deprotonated by any basic solution. Both sodium hydroxide and sodium bicarbonate are strong enough to deprotonate a carboxylic acid to form a water-soluble carboxylate anion. So if a mixture contained every type of solute, it's possible to isolate all 4 components with the proper acid-base extraction strategy. First, extraction with a mildly basic bicarb solution would react with the acidic carboxylic acid and remove it from the mixture. Next, a stronger base is used, A sodium hydroxide wash would remove any weakly acidic components, such as a phenol. Finally, extraction with an acid solution would remove any basic solutes, such as an amine. Any unreactive solutes would remain neutral throughout all of the extractions, so they would still be dissolved in the organic layer. The acidic and basic components could be isolated from their corresponding aqueous solutions by neutralizing each of the three aqueous layers and back extracting each with an organic solvent. Let's see if we could predict what will happen with a few examples of acid-base extractions. Let's say we have the following components dissolved in organic solvent, such as ether. We have a carboxylic acid, a phenol, and an amine. Now, if we mix that organic layer with aqueous hydrochloric acid, would any of these components move to the aqueous layer? Pause the video and make a prediction before resuming. If you guessed that the amine would be extracted to the aqueous layer, you're correct. The amine functional group is basic, so it would be protonated by the HCl acid, and the resulting ammonium salt prefers to be in the aqueous layer. To fully remove the amine from the organic layer, we would drain the aqueous layer, add a fresh portion of aqueous HCl, and shake again. Typically, 2 to 3 extractions will complete the transfer process. Now, what if we had the same mixture of compounds, but instead treated the organic layer with aqueous sodium bicarbonate? Pause the video and predict whether or not any of these components would move to the aqueous layer. If you guessed that only the carboxylic acid would be extracted into the aqueous layer, you got it right. This mixture contains 2 acidic compounds, but the weak bicarbonate base is not strong enough to deprotonate the weakly acidic phenol, so the neutral phenol stays predominantly in the organic layer. The carboxylic acid, however, will be deprotonated by the bicarbonate base, and the resulting carboxylate salt prefers to be in the aqueous layer. Finally, let's look at a different mixture of compounds. Here we have an ester, a phenol, and an amine dissolved in ether. What would happen if this organic layer was treated with aqueous sodium hydroxide? Pause the video and predict whether or not any of these components would move to the aqueous layer. If you guessed that the phenol would be extracted to the aqueous layer, nicely done. The sodium hydroxide won't react with the ester or the amine, so those components stay dissolved in the organic layer. The phenol, however, will be deprotonated by the hydroxide, and the resulting phenoxide salt would move to the aqueous layer. Thank you for watching this tutorial, and good luck with your extractions.